Hi guys, I'm not feeling better today. So I created this so that we don't get behind, and hopefully this will make sense. Um, we'll be able to spend some time in the next days going over it. Um, but please take this in your notes. If the substitute hasn't already passed out, the trigonometric identities handout, it should be a packet, 10 pages. Um, it's not the P set. It looks like this. Um, then please have that happen now, because you're going to take notes on pages 3 and 4 of this. You'll notice that there are a lot of formulas that we have done so far in trig, and there are a bunch more that we have not learned this year. You did them last year, but you know me, it's important to me that I prove all the things that I say, and that's what we need to do for these. So that's going to be how this is fundamentally different from last year. We're going to start with our sum and difference rules for sine and cosine, and the question that motivates this is there a way that we can rewrite sine of u plus v? Now, sometimes we'd rather have, say, sine of x plus y, or sine of u plus pi, or something like that. But frequently, we'll want to rewrite it. So how can we rewrite it? So the idea behind this is to create a triangle whose a right triangle, whose hypotenuse is 1, and has an angle that's equal to u plus v. Here, on the left, you see one of these triangles. On the left, you see this triangle is a right triangle. It has u plus v as one of its acute angles, and 1 is the hypotenuse of this triangle on the left. Before we go further, I want to just point out how we get all of the other things on the right. If we extend this line until we reach a perpendicular, we will always be able to create a right triangle here. Then from this right triangle, we can create a rectangle here, extending this adjacent side and extending the opposite side. So the other thing to note is that if this is u, then this angle, because this is a right triangle from this right triangle on the bottom, we have 90 minus u, because this is a triangle that adds up to 180 degrees. Now these two angles add up to 90 degrees, so this is going to be equal to u. These two add up to 90 degrees, so this is going to be 90 minus u. And then these two add up to 90 degrees, so this will be u. So the big idea here is when we create this diagram, this small triangle also has an angle of u here. That's a big deal, so if that didn't make sense, do label it in your diagram, and this gives us that as part of a triangle. These two make a right angle as part of a rectangle, so that's u. These two make a right angle because we forced this to be a right angle. And these two make 90 as part of a triangle as well. So now the important stuff here is this, that we have 1 is our hypotenuse here. We have a triangle whose angle is u. We have a triangle whose angle is v. We have a triangle whose angle is u. Okay, so what good does this do us? Well, let's look at different sine ratios, sine and cosine ratios. So if we look at, I don't really care which triangle we look at first. Let's look at this one. If we look at this triangle, you'll see that the angle is v, so all of the trig ratios that we write are based off of v. You should remember that if we have some sort of side length and angle, we can say that this is r sine theta and this is r cosine theta. And this is because sine is opposite over hypotenuse, so r sine theta over r is going to be sine theta. And cosine is adjacent over hypotenuse, so r cosine theta over r will be cosine theta. So what we can do is say 1 times sine theta is going to be over here. So we're going to have sine of, well, what's the angle? V. And this side is the adjacent side, so I can say this is cosine of V. Be very careful about getting your angles correct. That's going to make a huge difference as we go later in this process. Now, let's look at this this triangle here, this small u triangle. If we look at the small u triangle, the idea is that this is the hypotenuse, and what we can do is we can take the hypotenuse, multiply by sine theta for the opposite side, and multiply by cosine theta for the adjacent side. So if we multiply by sine of u, we get that the opposite side from here is sine v times sine u. So just again, that's from, this is the hypotenuse, so that's why I'm multiplying by sine v, and sine u is because we're looking at the opposite divided by the hypotenuse. Same thing works for the adjacent side. This is the adjacent side, so we can take the hypotenuse, sine v, and multiply by cosine of the angle. So this is sine v times cosine of u. You will want these written in your diagram. Okay, that's good. Now we have this triangle with the angle u. This side is the opposite side, so we can use sine of u times the hypotenuse. The hypotenuse is cosine of v, and sine of u. And this whole thing is going to be the cosine. So cosine v cosine of u describes this whole side. And it's important to note that when we wrote cosine v, we were talking about this whole side length. So that's why this is cosine v cosine u, not just this small part. Okay, so now we have most of the side lengths in this diagram. What's remaining is what's sine of u plus v, and what's cosine of u plus v. So what we can look at now is the whole triangle. If we look at this whole triangle, this is a triangle whose hypotenuse is 1, and the acute angle is u plus v. So this means that the opposite side, this whole opposite side, is sine of the acute angle, which is u plus v. And for this side, that is the adjacent side, so this is cosine of u plus v. Okay, now we have enough information to create formulas, because this side, based on the properties of a rectangle, this side is equal to this side. This side, based on the properties of a rectangle, is equal to this side. And now we have two things that add up to sine u plus v. In particular, let me delete that. In particular, this red side plus this purple side add up to the whole height of the triangle. So this is going to be our formula for sine of u plus v. It's sine v cosine u, cosine v sine u. What about for cosine? We can say that it's this whole thing minus this red piece. If we take the whole thing minus the red piece, we get this blue side. So cosine of u plus v equals cosine of v times cosine of u minus sine v sine u. So I'm going to write that down on the next slide. Sine of u plus v equals sine of one angle times the cosine of the other angle plus the cosine of the first angle times the sine of the second angle. Please make sure you have these written down. And cosine of u plus v equals cosine of u times cosine of v minus the sine of u sine v. Again, we got the subtraction in this problem because we had the entire length minus the small rectangle part on the right gave us the part of the actual hypotenuse 1 triangle that we cared about. This one we got from the rectangle. The rectangle's height and the triangle's height added together gave us the whole triangle's height. These are the sum formulas. The next video is going to be the difference formulas, and it's much faster.